Volume of pyramids, cones, and spheres. Given the same diameter and the height for each figure, drag them to arrange in order from smallest to largest in terms of volume. Let's start there. This cylinder actually looks pretty big. Let's see, can we fit this cone inside of it? Oh, we totally can. So the cylinder is still bigger. Not sure if the sphere or the cylinder is bigger. Oh, you can actually fit the whole sphere inside of the cylinder. Okay, that's interesting. So if we take the cylinder and then rearrange them this way, it kind of looks correct in terms of smallest to largest, because the sphere doesn't have as much extra white space around it as this cone does. Notice there's a lot of extra white space going on when you put the cone inside of the cylinder. So it seems as though this is definitely the order from smallest to largest, where the cylinder is the greatest. How many filled cones do you think it would take to fill a cylinder? It's a triangle, so it might be half, or it might be a different fractional relationship. So I'm not sure how many spheres. It's definitely a whole sphere and then a little bit more. Let's see if we can find out more. Let's actually look at a demonstration when comparing the volume of cones, spheres, and cylinders. So we see that all of them are the same in terms of height, like how tall they were. So first we got a cylinder. This cone okay, he's going to pour a liquid in this. Okay, one cone in the cylinder. He's going to mark where it came up to. That's one cone. Okay, let's see if two will fill it up. Oh, two didn't fill it up. Okay, this is going to be number three. 3 cones make up the volume of an entire cylinder. So therefore the volume of a cone is 1/3 the volume of a cylinder. Okay, I'm just going to get rid of the liquid. Now let's see what a sphere does. Remember, when it was placed next to the cylinder and cone, they were all the same height. Okay, so there's the sphere. He's dumping it in. Let's see where it comes up to. It's past 1/3 and half. It's right at the 2/3 mark. So therefore, the volume of a sphere with a set radius is equal to 2/3 the volume of a cylinder with that same radius value. And he's also showing how if you put a sphere and a cone together, you will get the volume of the cylinder. The volume of a pyramid is 1/3 the volume of a prism, with the same base area, or capital B, and the height, h. What would be the formula for the volume of a pyramid? Well, the volume formula is going to be 1/3 times the area of the base times the height. Now, sometimes you will end up having pyramids with different base styles. So if we had a rectangular base pyramid, its volume would be calculated by taking 1/3. The area of the base is length times width, and we have the height. Well, since in multiplication it doesn't matter what order you multiply numbers, we can remove those parentheses, and that will make the formula 1/3 length times width times height. If it was a triangular pyramid, its volume would still be 1/3 times the area of the base, which would be 1/2 the base of the triangle times the height of the triangle, and then you would multiply that by the height of the pyramid. Please note that these two height values are not going to be the same. Let's take a look at some examples to see how this is the case. Find the volume of the square pyramid shown below. Well, we know that the volume of any pyramid is calculated using the formula 1/3 times the area of the base times our height. Now, because we have a square pyramid, we can rewrite this formula to be 1/3 times the side length squared, because this 4 meters is going to be the same as over here as 4 meters. And then we have our height of the pyramid, which we are told is 5. So then let's substitute the 4 in for our S, or side length value, squared. And then if we square 4, we get 16, and 16 times 5 is 80, and 80 times 1/3 is 80 thirds, which you can also rewrite as a mixed number, which would be 26 and 2/3 square meters, or cubic meters. And here's the solution to the example problem that we just worked out. The volume of the square base pyramid is 1/3 area of the base times the height, and our base is a square that has side lengths of 4 meters on each side, and its height is 5 meters. And if we multiply 4 times 4 times 5, we get 80, and 1/3 of 80 is 26 and 2/3 cubic meters.